Welcome to Unit 8, Notes 1, Intermediate Algebra B. This is Mr. Hooper speaking, your well-rounded math teacher. Learning target for today, I can simplify a radical expression. So we're working with square roots to be more specific. Alright, so we're just going to jump into this. We're finding the prime factorization. So this would be similar to what you kind of call the factor tree in maybe middle school. Alright, so we're splitting 63. Everybody in the room at the time knows that 9 times 7 is 63. Now we're dealing with prime factors. So 7 is a prime number, so I'm done there. However, 9 is not. 9 I can break into 3 and 3. So now I have these two prime factors. So one thing we can do is write this as 3 times 3 times 7. This is good enough for us, alright? If you want, you could write it as 3 squared times 7, but you don't have to. That's optional. Then you look at 98. 98 is a really big number. You should see it's even, so I probably would have did it 2, just to see that it's 2 times 49. 49 only has one factor, and it's actually a common factor. It'd be 7 times 7. So then what I usually do is maybe underline and rewrite all my prime factors. And again, this one could be 2 times 7 squared. But right now, we just need you to be able to get to 2 times 7 times 7. 180 has a 0 in it. So if it has a 0 in it, you right now automatically need to know 10 goes into it. So then I probably would have wrote 18 and 10. Alright, I know that 18 has 2 and 9. 2 is prime, so we're done there. 9 goes into 3 and 3. So we'd be done now. 10, 2, and 5. So now this is kind of out of order. So I would have had 1, 2, another 2, then I would have went to 3 and 3, and finally that 5. So I underlined 5 numbers. I rewrote 5 numbers in order. So those are the prime factors. So the prime factors of 63 are 3 times 3 times 7. So that's something you guys should be reviewing. Alright, it should be something that you can work on and strengthen your number sense. Okay, so we have a Venn diagram of number sets. And what this is when you were a kid, alright, you probably, your parents or whatever it may have been, probably tried to get you to start counting. So you started at 1, and 2, and 3, and all the way up to maybe you learned about infinity. And all those numbers are the natural numbers. Okay, so we call those the natural numbers. And then we decided to teach you the whole numbers. And really the only thing difference between the natural and the whole numbers are that now you include 0. So it would be 0, 1, 2, 3, all the way up to infinity. And just make sure you know infinity is this symbol. If you didn't know what it was, alright, so it's all the whole numbers, alright. 0, 1, 2, 3. A half is not a whole number. A half is not a natural number. It's a whole numbers, don't have any decimals. Alright? Then as we go up in math, we get to integers. And now integers happen to include something that we don't have yet. Integers include the negative numbers. So now we go from negative infinity to negative 3 to negative 2 to negative 1 to 0 to 1 to 2 to ... infinity again. So integers includes the negatives. So whole and natural are all the positives. Wholes include the zeros. Integers include the negatives. Alright? And then we have what we like to call rational numbers. And rational numbers, rational, have this word ratio in it. So rational could be fractions. Alright, so maybe somehow we got to get fractions and decimals in here. So for example, 4/3 is a fraction. Decimal, maybe 10.6. Now, 4/3, interestingly enough, 4 divided by 3 in your calculator is going to equal 1.3 repeating. So a repeating decimal is still a rational number. I never really understood that right away. Fractions, numbers that can be written as a fraction or decimals, are rational. Okay, and then when we talk about these, red actually has rational, and then we have irrational. And now irrational, all right, are going to be numbers that don't end and don't repeat. So kind of the most common irrational number that most people think of is usually pi. Alright, and I'm outside of the circle already, but you should know irrational numbers are pi. Also common irrational numbers are square root 2. If you type square root 2 in your calculator, it's going to round for you. So the square root 2 doesn't actually end. It just rounds for you. A calculator rounds it. So square root 2 doesn't have an end. Square root 3 doesn't have an end. Square root 10 doesn't have an end. Now square root 10 probably doesn't have an end because 2 doesn't. If 2 doesn't, 10's not going to. So those square roots are a lot of times irrational unless it's a perfect square. And we'll talk about the perfect squares in a little bit. And then all of these, so everything, all the rational and irrational numbers are real numbers. Alright, so if they fall under one of these two categories of rational or irrational, they're going to be real. So the real numbers are basically what we're going to be dealing with all through high school. Once you get to Algebra 2, you're going to have these imaginary numbers that you work with a little bit. So imaginary. I-M-A-J-I-N-A-R-Y. Imaginary numbers. So basically what that looks like is we have a little letter I, and that's the square root of a negative number. So negative number. Or negative, let's make it -1. Alright? So like the square root of -16, in your calculator it's going to tell you syntax error or domain error. But once you get to Algebra 2, you're going to know that as 4i. The square root of 16 is 4. The square root of a -1 is I. You don't need to know that, but you will in Algebra 2, and you'll deal with it a bunch. Now, once we get to pre-calc, we'll start working with complex numbers a little bit. And those are going to be things like 8 plus 6i. So those are ones that have real numbers, like 8, and 6i, which are imaginary, and those are complex. So every number can be classified as a complex number, but then we have more and better terms to break those down. Right? This is a very good Venn diagram to have and you keep useful. Even when you go to college and you prove math equations, which sounds like a blast. I can talk to you about it more in detail in real analysis class, but you're going to want to have this Venn diagram handy. So radical expressions. All right, let's flip over to the next page. There any expression with a radical term. So we're going back to these radicals. No perfect squares under the radical, no fractions. We're not going to have any fractions ever. And we'll go with that. So then we're going to simplify, and we're going to use the prime factorizations of the numbers right here to simplify them. And if there's a variable with a power, write it in expanded form, and then pull out the pairs. So we're going to try and reduce these and make them easier to work with. All right, pause right now if you want to write this down and you're not finished. So simplifying the expression. So I have square root 50. Square root 50, I see, could be written, ooh, green and yellow, go Pack, go. Could be square root 2 Oops, I did this wrong already. Square root of 50. What I would do is I'd write this. I like this green and yellow combo. 2 times 25. Right? Because then I'd have 5 and 5. So then in my rewrite, I could write 2 times 5 times 5. The square root of that. Okay? What they're going to tell you is that you have 2 5s in there. You can take the 2 5s and write it as 1 out front. So this would turn into a 5 out front, then the square root, and then a 2. And this here would be your final answer. And we would say things like 5 root 2 or 5 square root 2 for answers. Okay? That's the lingo, that's the math lingo that you should know. Okay? So we're able to, right here, is the important part, take 2 of those 5s and write it out front as 1. It's really down here. Write it out front as 1. So let's try that a little bit. Alright? 48. So 48, I would say it's probably 4 and 12. Alright, then I'd split up my 4, 2, 2, 6, 8, 2. Oh my goodness. This yellow is tricky to use. 2, 2, 2, 6, 2, and 3. So now, I used to always underline. So I have 4 2s. 2 times 2 times 2 times 2 times this last 3. So all 5 letters are included. So how many groups do I have? I have these groups of 2s can go out front. These groups of 2s can go out front. So I need 2 to write 1. So I'd write 2 times 2 times the square root, and there's only a 3 left. So the best answer here is 4 root 3, or 4 square root 3. Right here, we get a lot of questions about that. Instead of 4 and 12, some people are going to do 2 and 24, or they're going to do 6 and 8. It doesn't matter how you start prime factorization, as long as you have the same thing here. If these 2 lines are different, no, that line can't be different. If you're beginning here, square root 48, these starred ones are the same, it doesn't matter. The middle doesn't matter. You just have to know how to get to that last step. So square root 32. I'm probably going to do 4 and 8. And then I know 2, 2, 2, 4, 2, and 2. So 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So I just have 5 2s here. Now, I have an odd number of 2s, so I know that my groups here, it's going to be these 2 out front and these 2. So I would have wrote 2 times 2 times the square root, and then I just leave this one in. It's 2, so it's 4 square root 2. Those are the values you need to be able to get. Remember, when you're taking notes, try to pause the video once in a while and do a problem on your own. Then you can see the difference between the way I'm thinking and the way you're thinking. And I'm not always right. So if there's an easier way to do it the easy way. Or ask questions. Come find me and we can make sure you're doing this right. So those are the options. Now we got a couple where we're going to look at x to the 4th. So it says on that cheat sheet of rules of how to do these to write variables in expanded form. So I have 4 of them. Remember, 1, 1, 1, 1. You add exponents when you multiply fractions. So that would add up to x to the 4th. Now, these 2 are a group. These 2 are a group. So I would actually make this one x, make this one times x times square root. There's actually nothing left in here. So let's just x times x. Remember, 1 and 1 is x squared. That's the best answer there. So when you deal with variables, just write them out and see how many you can pair together. Here, both of them paired together. So then like 4, I would have probably started with 2 and 2. So then I can see my square root. If I brought that down, it would be 2 times 2 times b times b times b. Okay? These two and these two, I pull out. I'd write 2 times b times the square root, and there's a b in there. So the best answer here is 2 times b times the square root of b. Notice we don't always write the dot for multiplication because it kind of just goes away. Alright, mathematicians are famously lazy. That's why I'm so well-rounded. Alright, me and Picard both. We just are living the dream. Alright, so 75. I'd probably do 5 and 25. That's not right, so don't write that down. Probably would do 3 and 25. Alright, so then I'd probably get my square root. I make it nice and long. I do 3 times 5 times 5. Remember, it's 3 because of 3/4 is what I was thinking. Y. Maybe I'll do this in a different color. Y's are the 5s I'd write here. The X's I'd write times X times, looks like a group of Y's. Square root, what do I have? I have a 3 and a Y left. So I just write this nice and neat with no multiplication symbols. Because if nothing's written, that means multiply. So it's 5 times X times Y. So that's what you're looking to do. You're trying to find the groups. Alright, if you find a group of 2 inside the square root, you can pull it out front. And obviously prime factorization helps with that, so it's a little bit easy to see. Alright, so now there's a simplifying radical expressions using perfect square. Determine the largest perfect square that divides the number. Use the product property to rewrite the radical expression. So right here, we're going to do a bunch of rewriting like this, but it should be easier. Then we don't actually have to find the prime factorization. We can just use our knowledge of perfect squares and our education that says, hey, we can break up square roots and write them as multiplication still. So what I want to show you is that we first need to know the perfect squares. Perfect squares, 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49. Isn't this a lot of fun? Alright, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196. Alright, if you can do all of these, that's awesome. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. And 20 times 20 is 400. Alright. Those are the values that you should always be looking for when you're trying to simplify radical expressions. Alright, so when I use radical expressions, I'm going to show you the way I do it usually, but you have to have a knowledge of numbers, and that's knowing the perfect squares. So right here, we have the perfect squares. Now we have 10. Number 10 says square root of 24. 24 has two numbers, or a couple different numbers that go into it. But my square root of 25 is 5, so I know it's a number less than 5. Alright, now square root of 16 is 4, but 16 doesn't go into 24. Square root of 9 is 3, but 9 doesn't go into 24. So the only thing I can get, and I used to always write this as square root of 4 times the square root of 6. 4 times 6 is 24, so these lines are both equal. Now the square root of 4 is actually 2, and the square root of 6. This is all you would have to do. Right? 2 square root of 6 is the correct answer. So I usually write it by bringing the square roots down here, and then just take the one that we know. So 98 was on the front. We started with it. We took a 2 out and knew that it was 49. So I write the square roots because I don't want to forget what I'm doing. Square root of 2 is the square root of 2. Square root of 49 is a 7. Usually we never write this because sometimes kids will do 2 times 7 and write square root 14. We don't want to do that. What we usually do is we'll write this out front so that it's 7 root 2, or 7 square root 2. I want to keep that as simple as possible, and we usually put whatever value whole numbers being multiplied by out front, and then following that is the square root of 2. So then we have the square root 12, number 12, 3 square root 18. 18, I would probably write a square root 2, square root 9, leave the 3 alone. This is the one where I would take the square root 9, probably write it maybe in the middle, so that you see it's square root 9, square root 2, right? Then it just becomes 3 times square root of 2, or 9 root 2. That's how my brain processes this. Square root of 9 is kind of just easier right here to see that if you write it in the middle, that's what you're doing. Sometimes I'll jump from this step to here, just because I know the square root of 9 is 3, and I want 3 times 3, which is 9. If you look at 12, not much goes into 12, besides the only square root I know is the square root of 4. So maybe I could just be smarter and write the square root of 4 in the middle instead of having to move it all the time. Square root of 4 is going to be 2 times the square root of 3, so the best answer here is 10 square root 3. And so those would be the values that I would look for all the time. Alright, so this is a tsunami. Bunch of reading. A tsunami is a destructive, fast-moving ocean wave that is caused by undersea earthquakes, landslides, or volcanoes. Scientists can predict the arrival times of tsunamis by using water depths to calculate the speed of the tsunami. A model for the speed, s, in meters per second, at which a tsunami moves is s equals the square root of gd, where d is the depth in meters and g is 9.8 meters per second. Sounds good. Here's the deal. That's hard to read on here, but it's in front of you. Now, it says find the speed of the tsunami in a region of the ocean that is 1,000 meter deep. Write your solution in simplest form. So in our directions of that paragraph I read, it says s equals the square root of g times d. So the speed is equal to the square root, and it says gravity is 9.8 meters per second. So we have 9.8. Now it says the depth here is 1,000, so we would write 1,000. Right? So our speed is equal to the square root of 9,800. Now, for me to do this, I want it in simplest form. For me to write this, I would write s equals the square root of, the one I always see is 100. Now we did 98 3 times now, and every time it's been 100 times 49 times 2. So this is all under the square root. I then probably would write s equals, and I'd probably write it as square root of 100, square root 49, and the square root of 2, and break all those up, because this is going to be 10 times 7 times square root 2, which is just the speed, is 70 square root 2 meters per second. Meters per second. That's how I would do this. So A is, when it's 1,000 meters deep, it is going to be 70 square root 2 meters per second. Alright, I'm going to get rid of this, so make sure you have that down. Now B. So B says, find the speed of tsunami in a region of the ocean that is 4,000 meters deep. So we're just going to up it one. Alright, we're going to go to speed. That's a bad color. Speed equals the square root of grad GD. Then we're going to go speed equals the square root of gravity, which is 9.8 times 4,000. Now what that does is it gets rid of this decimal for me, which I like to do. And this is going to be 39,000 200. Now I'm going to let you in on a little secret. You multiplied 4 and 9.8 there. This really is the same thing as 4 times 98 times 100. So you can check that if you want. You pull the 100 out, you're left with 392. You pull the 4 out. Since you guessed and checked, you get 98. So I probably would write this as square root 4 times 100 times 49 times 2. Because then everybody should see that that is the same as S equals, I don't know, we're going with purple. I didn't want a big square root, I'm going to break it up. So I like to write it as the square root of 4 times the square root of 100 times the square root of 49 times square root 2. So this is going to equal 2 times 10 times 7 times square root 2. 2 times 10 is 20, times 7 is 140 times the square root of 2. So when it's 4,000 deep, that is just a speed of 140 square root 2 meters per second. Alright, I'm going to erase. So we'll make sure you got all that. And then we got to answer C. So if you look at your answer for A and B, you're going to need them here. So C, critical thinking. Is the speed of tsunami, what? Alright. Try it again. Critical thinking. Is the speed of a tsunami in water that is 4,000 meter deep 4 times the speed of tsunami that is 100 meter deep? So what we had is we had 4,000 meters deep versus 1,000 meters deep. Now when we did this, our 4,000 meters deep ended up with an answer of 140 square root 2 meters per second. So this is speed. And our 1,000 meter deep one only had a speed of 70 square root 2 meters per second. So it asked when 4,000 times bigger, so when I go from the 1,000 to the 4,000 here, it's times 4. Well, when I look at their speeds, 70 times 2 is 140, so this is actually only times 2. Why or why not? So it's no. It's not 4 times bigger. Why or why not? I would say because the equation is a square root. Should write out square root. Hence, if you start with 4 times bigger, the square root of 4 is equal to 2. So answer twice. Or answer double in value. I don't know. Answer twice in value. I'm not an English teacher. I don't think twice in value makes sense. Double in value is a better answer. Alright? So you got to be able to explain that. So some of these equations where you start with a speed 9 times as great and you take the square root of it to find an answer, it's going to end up being triple the size. Square root of 9 is 3. So that's radical expressions. So radical expressions are going to have these square roots in them all the time, and you're going to manipulate them into something more simplified. Thanks for listening today. Have a wonderful day.